This video, we're going to take a look at what happens when we have measurements with known numbers of significant figures that may or may not be the same, and then we're going to calculate other values. So we're going to calculate, we may add numbers, multiply, divide, for example. So let's get started with that, please. Let's see. Figures. All right, so what happens if you have two numbers and you want to multiply or divide them, or more, you might have 3 or 4 numbers in sequence that you want to either multiply or divide. So there's 4 steps. The first step, determine number of significant figures of each number. So you look at each of the numbers and the numbers that you're going to be multiplying or dividing. And then you find the minimum number. So after you've looked at, if you evaluate how many significant figures in each of the numbers, find which one has the minimum. So if one has 4, another has 3, another has 2, then you're going to choose 2 as that minimum number of significant figures. Then you calculate the product or quotient, in other words, either multiply or divide, using all of the digits in all of the numbers. And finally, you're going to round off using that minimum number of significant figures. So in our example I just described, where you had 4, 3, and 2 significant figures in 3 different numbers, we're going to use that 2, and we're going to round off our answer to 2 significant figures. So here's an example. So we're going to multiply 5.835 times 7.2 times 3.5 and then divide by 9.758. And you can see here that this one has 4 significant figures. This has 2 significant figures. 3.5 has 2 significant figures, and this one, 9.758, has 4 significant figures. So I think we can readily see that 2 significant figures is the minimum number of significant figures of all the numbers that we're multiplying. So that's basically why we wrote here, 2 significant figures. That's that minimum value. Now we use a calculator and we come up with this number, 15.06886657.1, and probably we could add another 10 digits if our calculator would provide that. However, we know by our steps that we're referring to, we're going to use this minimum number of significant figures, in this case 2, and we're going to round off 15.06886657.1 to 15, because we look at the next number. In other words, we take our 2 significant figures, and then we take the next one over. If it's from 0 to 4, then we leave this. If this were 5 or greater, 5 to 9, then this would become 16. Number of digits to be removed. Oh, so round off. We didn't really talk about round off before. Let me get to that. So the number of the digit to be removed. In our case, let me look at that last. In the previous example, we had 15.0, and then we had a bunch of other digits. That's 0. That's the one that's going to be removed because that's our 3rd significant figure, and we only wanted to retain 2. So if the number being removed is between 5 and 9, then you're going to round up the next number up. So the 15.0 would become 16. If the number being removed is between 0 and 4, then we're going to round down. Okay, so in this case, we rounded down from 15.0 down to 15. We'll work out some more examples. Here's some examples right here. So let's say we want to take the number 5.834, round it to 3 significant figures. So the number we're eliminating is the 4, because we're going to retain the 5, 8, 3, right? 1, 2, 3 significant figures. In this case, it's between 0, this 4 value is between 0 and 4. So then we round down to 5.83. On the other hand, in this case, we have 5.835. And if we're also rounding this one to 3 significant figures, in other words, we're retaining the 5, 8, and then this one is basically uncertain, the 3, and we're going to get rid of the 5, right? Because we have 1, 2, 3 significant figures. In this case, the number being removed, the 5, right, it's between 5 and 9. which means that the next digit up is going to be increased. In other words, we're going to round up rather than down. We end up with 5.84. Same thing happens here, 5.835 is two significant figures. So we're going to keep the 5 and the 8. We're going to get rid of the 3. Because the 3 is between 0 and 4, we're going to round down to 5.8. All right, so we've gone through the rules of how we multiply and divide numbers. What I want to do is to run through a quick, I wouldn't call it a proof, but just a kind of a demonstration of why we do it, or at least proving to you, giving you some sense of confidence that using these rules are reasonable, is a reasonable thing to do. So I pulled out an example where we're going to multiply 3 different numbers, and in each case, the number is known with a particular level of precision defined by its confidence interval. So for example, in this case, we have 321 plus or minus 1. So the plus or minus 1 indicates that this number 321 might be as high as 322, it might be as low as 320, but our best guess is that it's 321. Okay, we're going to do the same thing here. We have 20.0 plus or minus 0.1, 0.1, and 4.27 plus or minus 0.01. So you see in this instance, we have 3 numbers with each of which have 3 significant digits and are significant figures. However, the confidence interval varies from 1 to 0.1 to 0.01. Okay, so what I'm going to do is we're going to try to we're going to multiply these first using the maximum value. So it'll be like 322 times 20.1 times 4.28. That'll give us kind of the maximum range that we might expect to get if for example, all 3 of them happen to be at the top range of their confidence interval. Then we'll use the middle value, so we'll multiply 321 times 20 times 4.27. And then we'll do the reverse that we did before, but we're going to use the bottom of the range. So it'll be 320 times 19.9, in other words, 20.0 minus 0.1, and 4.27 minus 0.01, which would be 4.26. So it should give us a kind of a feel for what happens if these are, for example, 3 measurements. What happens if in each case we're biased low or biased high, or if we're actually hitting the actual values. So that's what we're looking at here. So you can see we're calculating 320, 19.9 times 4.26. We end up with 2.71 times 10 to the 4th. That's essentially the minimum value. In other words, if all the values were at the bottom, we're at the essentially the midpoint minus the confidence interval. Then we're going to use the midpoint. We end up with 2.74 times 10 to the 4th. And then you can see in this instance we're at 322, which would be like 321 plus 1. And we're adding each case the confidence interval on, is presuming that we're kind of at the high end. So you see the result here. We end up with 2.71 times 10 to the 4th, 2.74 times 10 to the 4th, 2.77 times 10 to the 4th. So this is kind of this is exactly what we might expect, in which the first 2 digits are exactly known with total accuracy. In other words, they're unvarying. And the 3rd digit has some imprecision to it. In this case, it can vary from 1 to 4 to 7. So if we saw a number like that, you remember before we were talking about significant figures, we would say that this number has 3 significant figures. So in fact, that's exactly consistent with our rule, which in this case we're multiplying 3 numbers, each of which has 3 significant figures. The result will in fact have 3 significant figures. So that we're basically, our rule is coming up with a result that's consistent, internally consistent. What we're going to do now is we're going to reduce this 4.27 to 2 significant figures and see what happens to the result that we get. All right, so in this instance, because we're multiplying a number with 3 significant figures, another number with 3 significant figures, and a third number with only 2
two significant figures, we'd expect our result to be known with two significant figures. In fact, that entirely is what we end up with. Because in this case, you see, here's the result. As before, we have a minimum, a mid, and a maximum value. The first one is known with entire confidence, and the second digit in this case is known with not is varying. It's known with some imprecision. So in this case, we would expect we would call this result to have two significant figures because it has one number that's known totally precisely, then it has another second digits known basically imprecisely. So our rules essentially are consistent and produce a result that is entirely what we might expect it to be. And in fact, in going back to that idea of those rules, you might want to go through that exercise yourself to kind of convince yourself that in fact, because it's a little difficult to follow that discussion, I think, without doing it yourself. Now, adding and subtracting, it's similar to multiplying, but it's a little bit different. And first, I'm going to give you the rules and how it's done. And the rules are actually kind of difficult to understand, but then we'll go through an example, and I think it'll be obvious, and it's actually quite easy to do. Okay, so you're going to do it in two steps. We're adding and subtracting two numbers. So the first thing you're going to do is you're going to find the column of the least significant figure for each number. So that essentially, if you have numbers, you're going to go to the far right of each number and identify what that number is. So maybe it's like in the 100th column, it's in the 10th column, or it's in, say, the 1000th column. You're going to identify what is the column of the least significant figure for each number. And then use the leftmost of those columns that we just identified. That's the last significant figure of the response. So I'm going to show you what that all means with an example, because it's a little bit difficult to just follow that in the abstract. All right, so here's the case. So we're going to add these four numbers. You can see that each one of them it has different numbers of significant figures, and moreover, the last digit varies. This one is in the 1/1000th column. This is in the 1/10th column. 1/10th column and 1/1000th column. So again, the first step is find the column with the least significant figure for each number. So that just means basically going to the far right and identifying that. So this one, as I said, it's in the 1/1000th, 1/10th, 1/10th, and 1/1000th. All right, in the next step, we're going to all right, let's go to step 2, which is that we use the leftmost of those selected columns, which becomes the last significant figure of the response. Let's see if we can figure out what the heck that means. So previously we had selected the lowest column for each one. So we had this column here for this number. That's the 1/1000. 1/10 for this number, 1/10 here, and 1/1000. What we're going to do, we're going to grab the leftmost of those values. Essentially, it's like the lowest, or it's the precision that's common to all these values, or at least the number to the right that's common to all four of those numbers. Okay, so that's what we're going to do. So we grab the leftmost of those columns. So the leftmost of those columns happens to be the 10th column. So we're going to use all the values to the left of that. We're going to use the 6. We're going to use the 10th column, and then we're going to throw out everything else. That's what we mean by the last significant figure of the response. The last significant figure would be essentially this number in the 10th column. So we're going to add these all up, ignoring the round off issues, and we end up with 6.777. And then we're going to round this number off. We're going to retain the 10th column. And remember, the 7 is between 5 and 9. So this essentially gets rounded upward to 6.8. after you've done it a couple times, you'll find that it's actually quite easy. Now, what if you have essentially what we might call a complex function? We have parentheses, exponents, multiplying, dividing, adding, and subtracting. What you're going to do is you're going to do them in this order. Do whatever's in the parentheses first, apply the exponents, multiply and divide, and then add and subtract. And in each case, you're going to round off following the appropriate rules. So let's follow through with it.
All right, so we're going to deal with this example of where we're multiplying two numbers, and then those get multiplied by the sum, which is applied within a parentheses. So we know the rules. We do the parentheses first. We apply our round-off rules within the parentheses because we're doing summation within the parentheses, apply round-off rules, and then multiply these numbers, and then apply the round-off rules that apply to products. So let's see what exactly that means. All right, so the first step is to work within the parentheses. So we add up these numbers within parentheses and not really pay attention to the round off, at least initially. And then in the next step, what you'll see is that we will deal with this. We know that that leftmost common column in this case is the tens column. So we're going to round off this 16.755, which was our sum of these three numbers, and we end up with 16.8. Now we have left is the product of three numbers, one of which has three significant figures, one has four significant figures, and the third has three significant figures. So as you might expect, we're going to end up with a final result with three significant figures. So let's go ahead and multiply that out. So we multiply it out without regard to the significant figures, and then round it off, as I was saying, to three significant figures. So the number we're getting rid of is that 1 is between 0 and 4, so we round down to 308. Okay, so keep that in mind, 308, because we're going to come back to that in a minute. I did want to discuss that in my own experience in working in the engineering community, that while we all understand that there are these rules, that it's not commonly applied exactly the way you're taught, the way I taught you just now to do so. What's usually done is that we will put all these numbers either in a calculator or a computer code, or we might multiply and add and subtract numbers using Microsoft Excel, that's a spreadsheet. And then at the very end, we round off the result. So instead of from the previous example, that we added the numbers within the parentheses and then applied the appropriate round off rules. And then we multiplied the three numbers, and then at the end we determined how many significant digits we should retain of that. Typically, that's not what's done. What we do is we put all these numbers and do our calculations, and at the end we do the round off. And you might end up with a slightly different result. So for example, I'll demonstrate. All right, to better understand the impacts of how we do these summation or multiplying or any of the calculations we do, and using the appropriate or the correct rules, and I'm putting that in quotes, versus what we call common practice, or what I call common practice, I thought I'd do the same example that we ran before, 5.50 times 3.335 times the sum of these three numbers. And typically what would be done is these are just thrown into a spreadsheet, calculator, computer code, and we end up with the number 307.328. We're not blind to the issue of significant figures, and most engineers would appropriately decide to round it off to three significant figures, which in this case will end up with 307, which is in fact, less than the value we got before. Remember, we had 308, but the error, the lack of precision is basically about 1 over 300, which is about, in this case, like 1/3 of a percent. So it's basically an acceptable given the imprecision in our initial numbers. And it's most people are not going to be too concerned about that. So that wraps up our discussion of calculations of numbers with different significant figures.